Welcome to Robert Morris University Math 0900. This is Brianne Pernick, and we are now going to begin Chapter 7, Lesson 5. In this section, we are going to learn how to graph linear inequalities in two variables. We do not have any new terms for this section, so we can move right into the objective. When you are graphing an inequality in two variables, and remember the term two variables just means that we're going to have literally two variables like a y and an x, or maybe a w and a v, two variables of some form. When we're graphing an inequality in two variables, the first thing that you want to do is solve the inequality for y by placing it in slope-intercept form, so to speak. Second, you want to graph the inequality as if it were an equation using the y-intercept and your slope. Now this is where the difference comes in. If the inequality contained a less than symbol or a greater than symbol, you would graph with a dotted or dashed line like that. And the purpose there is to indicate that the values along that line are not included in your solution set. Remember, less than means it's any value below that number, but not including that number. Greater than would mean any number larger than, but not including that particular number. So when we use the dashed or dotted line, that indicates that the values that lie on that line are not included in the solution set. If your inequality contained a less than equal to or a greater than equal to, then we graph with a solid line, and you would want to put arrowheads on the dashed line too, by the way. You would graph with a solid line. Using the solid line indicates that the values that lie on that line are included in the solution set. So that includes that equal to portion that accompanies the less than equal to or the greater than equal to. Lastly, once you graph the line, you are ready to shade your graph so that you or your viewer can know where the solutions lie with reference to your inequality. So if the inequality contains a greater than or a greater than equal to, you will shade above your line where the values are greater than the values on your line. If the inequality contains a less than or a less than equal to, you will shade below your line where the values are less than the values on your line. Now, I went through a ton of instructions, so what we need to do now is actually look at an example of how this is going to work. So if you remember, the first step that we had here was to put our inequality into slope-intercept form, so to speak. So we want to pretend that we have an equation and we want to solve it for y. Let's start there. The first thing that we need to do is subtract 5x from both sides. So I have 3y is greater than negative 5x plus 15. Next, we want to continue to isolate y, so we're going to divide everything by 3. So I have that y is greater than negative 5/3 x plus 5. Now that I have my equation, or my inequality, solved for y, I can go ahead and graph my inequality using the y-intercept as well as the slope of that line. So I'm going to start by putting a point on positive 5 because that was my intercept. My slope is negative 5, 3. So that tells me I need to move down 5 units and over to the right 3. And that's where I will put my second point. Since my inequality is just greater than, I want to use a dashed line that goes through those points. And put my arrowheads on. And then lastly, the symbol is greater than, so we will shade above the line to indicate that we want all of the values that are greater than the line. So what this tells us as we're looking at the graph is that any point, any ordered pair at all that lies above the line in the shaded boundary will be a solution to that inequality. You could plug any one of those points in and it would make your inequality true. Now let's go ahead and look at example 2. We want to follow the same steps. We want to solve it for y. So we're going to divide everything by 2, and I have that y is less than equal to negative 3/2 x. Now please note that I don't have a plus or minus anything at the end. When that occurs, that's like having a plus 0 at the end. That means that your y-intercept is 0 and that your line is going to go through the origin. From here you will use your rise and run, so we're going to move down 3, 1, 2, 3, and over 2 to the right. And then we will use a solid line since we have a less than equal to. That equal to tells us we need to use the solid line. And since the inequality symbol was less than, we're going to shade below the line where the values are smaller than my line. So in this situation, any value that falls along the line will be a solution to the inequality. And any value, any point that lies within the shaded area will also be a solution. So we can plug any one of those ordered pairs in and it would create a true inequality. At this point, I would like for you to go ahead and try student practice number 1. Please pause the recording. As soon as you're ready to go over the answer, please press play and we will check your work together. Okay, at this point you should have had an opportunity to complete student practice number 1. The first thing that you should have done here is isolate your y. So we want to subtract x. Oh, that was not supposed to happen. Let's get that back to where it belongs there. One moment, guys. Okay, we should be good to go there. I fixed our little mistake there. So the first thing that we need to do is start by subtracting x from both sides of the inequality. That is going to leave us with negative y is greater than equal to negative x minus 10. Next, we want to divide both sides by negative 1. Please don't forget the rule that tells us that if we divide or multiply an inequality by a negative, we must reverse the inequality symbol. So that reverses it from greater than to less than equal to. So now we will take care of the division. Negative 1 divided by negative 1 leaves us with positive 1x. Negative 10 divided by negative 1 leaves us with positive 10. So we now have our inequality that is in slope-intercept form, so we can now graph that. So I'm going to put a point on positive 10 since that is my intercept, And my slope tells me to move up 1 and over 1, up 1 and over 1. Remember, that slope is 1. So if we think of that like a fraction, that's 1 over 1. Now, since I can't move up and over to the right, what I'm going to do is move down and then to the left, and down 1 and to the left, and down 1 and to the left. That is essentially the same as moving up 1 and to the right, up 1 and to the right. Now, we do want to have a solid line since we have a less than equal to. And then the shading will be below the line to show that we have less than. So any point that falls on my line will be a solution. Any point that falls below my line in my shaded region is also a solution to that inequality. We have one more student practice example for you to complete. Please pause the recording, complete the example, and as soon as you're ready, please press play and we'll go ahead and go over the answer together. Okay, at this point you should be ready to go over the answer with me. The first thing that you should have done here is divide both sides by 2 so that you can isolate your y. So you should have x over 2, or we can think of that as a 1/2 x so that we can see our slope a little bit easier. Since we don't have a b at the end, we're not adding or subtracting anything, that tells us that our intercept is 0. It's technically like a plus 0, we just don't write it. Then we will use our slope. We want to move up 1 and over 2. We can do it again if we want, up 1 and over 2. We have just a greater than symbol. We want to use a dashed line to show that there is no equal to component along that line. And then lastly, since it's greater than, we're going to shade above the line. So what this tells us is that the dashed line is the boundary. Nothing along that line is included as a solution, but everything above the line within that shaded region is. We have one more example here, and this is going to be an example of an inequality that's just in one variable. However, this one is going to, if you remember, be a vertical line because it's going to cut through that x-axis. So what you do in this situation is we're going to have a point on -2, and then we need to decide whether or not we should use a dashed or solid line. For this problem, since it's a less than, we would want to use a dashed line that goes through x equals -2. And since we want any value that's less than -2, look at your x-axis. Which side of that line would the values be less than -2? Are they less than -2 over here where we have 1, 2, 3, 6, 7, 9? These numbers are larger than -2. We do not want to include them in our solution set because x should be less than -2. If you look at these numbers, -9, -7, -4, they are all smaller than -2. So that tells us that we should shade on the left side of our line. So any number that falls on the left-hand side of that dashed line is going to be a solution to that inequality. That is the last example that we have for this section. If you have any questions at all about the content that we covered here, please feel free to contact me and I will be more than happy to work with you. Thank you.